Okay, let's see. What do I have to do now? I think I was done with file type. I'm done with the tile. I'm done with tile rendering. And I'm also done with updating the tile and the camera. Okay, now I want to load media. Right, I have to load this media. So let's download the source. Yeah, sure. If can I? Okay, I cannot do that. Right, that's okay. Extract. There you go, 39, and I need these lazy dot. Okay, plus and lazy dot map. I will drop it into assets. Then what I want to do now is we will go define this function. Load media tiles, right? So we will go to game.c. I want to define this load media tile. Right now I'm only loading this. Yeah, I want to tile.h. I think I have a tile texture. I have defined tile texture, right? Tile texture. So I have already defined tile clips, right? Okay, so we have this. And then these are globals. A tile array of tile pointers, and it should not be 10, though tile. Okay, total tile sprites, right? Tile clubs, tile texture. Forgot why tiles was here. In tiles, I think isn't this? I have tile clips. STL rect tile clips. Okay, then I want to have 10 tiles. Do I declare 10 tiles? I don't know. Do we declare 10 tiles? Do we declare 10 tiles? I don't remember declaring 10 tiles. Total tiles are 192. So I don't. I think might have given it an arbitrary, right? Because when we, I'll get it when we go over the tiles. Okay, let's just load it, right? Okay, who is saying who? Okay. So we have, let's load the tile texture. Let's go over here, session load media r equals texture load from file g window renderer and tile texture assets slash tiles.png. We check should not be equals to false. There we go. Error, fail to load the tile texture, and I will fail to load the dot texture. So we'll make it again to see if everything is right. Okay, everything is good. Okay. Now I also have a function load tile map. Just set tiles. Okay. So we go over to this function map the field. Okay. We go load tile map. We will also LOD load the dot texture, load the tile texture. Set the tiles in the scene. Okay, so we go set tiles. I think I should have defined a function. Impossible. Okay. Yeah, this tile. Have I defined it here? Touches wall, destroyed, and nope. Okay, so this function should this function should really be a part of the game. So I'm going to shift it, or should it be a part of the set tiles? Okay. I think yeah, it should be a function over here. We'll declare static. I don't. I'm finding it a little puzzling. Sets the tile on the tile map. Set tiles. Okay. So, okay, what are functions am I doing in? We go load. We declare tile loaded. Then we have x and y offsets. Then we load up the file. Unable to load the file. Thus, I less than total type. We read the tile type. Then we go if tile type greater than 0. If the number is a valid number, less than total tile sprites. We go tile of I equals new tile with a tile type. And how are we increasing x and y? Right, because these I don't see how they are being increased. X and x y 0, they can't all be at 0. You should offset them, right? Okay, I think it reads x and y position. Does it? I don't think it does. There are no xy positions. Okay, yeah, there we go. Plus, if x have gone too far, move x, and we move to the next row. Right. Okay. Tile club. So I have tile pointers. Tile. What are we using these tile pointers for? Okay, tile of I. So I'm gonna have to declare a total tile sprites. Okay, so total tile sprites. What is total tile sprites time? And I going with total tiles, right? Okay. So I am declaring this with total tiles. Okay, first of all, let's see if it even allows for great memory. Everything's great. Yep, everything's great. Okay, so we have a static array of tile pointers. and initialize tile pointer is that hash, and I go set up tiles here. Tiles, and I can ask for scar tile map, right? Set tiles from the given tile map. Okay, then we go but then it doesn't know about level width and all other attributes, right? So this function should really be a part of the game. Let's say additional functions. Okay. So we go with this. We don't really need the okay. Free. I'll call free on this main dot destroy. Close the window. Deallocate all the tiles. So we go for int I equals 0, I less than total. I can go size off because since it is a size of tiles, not files, tiles, and we go I plus plus. Then we check if tiles of I, then we free tiles of I, and that's straightforward. So let's try and do that again. Okay. Yeah, okay, so it didn't really global buffer overflow and address here at yeah. Global value could defined in it's 0 bytes after global tiles defined in of size 1536. Okay, what happened? Yeah, free. Okay, so shadow bytes on the buggy address. So one shadow byte represents 8 application bytes addresses this, and it is aborting. Okay, and if I build it, is the make file. Okay, so we subble make file. Okay, we have window, we have Windows, Linux, debug, and let's also define a release. Right, CF flags, libsl. Please we go C flags equals dash o2 dash I slash headers. It's a release L, and then I go release L. I want to do compile the same for all, and then we go link L, I think link L, yeah. Okay. Okay. Link, I'll leave is just this. Okay, so I can just go link, right? Link. Okay, so we go make clean L and then make release L. Ah, shit. Okay, so I think link L has this, link S has this, libs. Yeah, okay. Link R. Okay. Well, let's try that and looks fine. And okay, it does give a segmentation fault, which is my bad because okay. So I don't think it will give me that. So make clean L now. Make release L. Right. Should not. Yeah, okay. So it is this condition. And I should init, right? So I should okay, it's a good thing to initialize your array of pointers, I guess. Okay. So I guess so. I go for literally this loop. Okay, it should be valid now. I don't wish to do that. I just want to go tiles of I equals null. Okay. Then we go make clean L and make Linux, then it's yeah. Okay. Now there's something wrong. I did do something on global variable quit of size 1. Quit is ASCII string. This is allocated 0 bytes after global variable tile. Okay, which is a problem because okay, bool equals false. We have an array of this. Then we go in having okay, right, if I tiles of I equals null, tiles of I equals null. 12 tiles. Then I go I size of tiles. If tiles is not equal to null, tiles of I, doesn't that still make clean L? Okay, clear. Make Linux. Hmm. Okay. So add a global buffer overflow and address at this. Right of size 8 at thread 2. Okay. Main dot age styling. Okay. Is allocated 32 bytes before global able quit defined in source of size 1. Quit is ASCII string. This. Okay. Is allocated 0 bytes after global and is allocated 0 bytes and global buffer overflow. Shadow bytes surround bug address. What are shadow bytes? 1 byte of value of 0 in the shadow indicates that all 8 bytes of the corresponding memory are accessible, while n, okay, n greater than equal to 1, 7, okay, n greater than equal to 1 or less than equal to 7, generally first n bytes are accessible and the remaining 8 bytes are not accessible. So, okay, and okay, seriously, I think just by doing that, make clean L and make Linux. I think just by doing that, okay, so I feel like I'm accessing this memory, that's why it is giving me these errors. I am accessing this memory before I allocate it. To allocate all the tiles. Okay, but I can also go right. Tiles equals 0. Would that be wrong now? Because I can initialize it like that, and then I won't have to deallocate it. Then does not equals to null. So we go make clean L clear and make Linux. Let's see if I still am having the problem. No, right, because I have initialized right. Nice, all the tiles too. Don't forget to initialize it. No, I'd say if, but since all of them are zeros, make clean L. Yeah, but if it is a global variable, by default it should be 0, right? Because uh, any declaration outside function takes zeros. Make clean L, make Linux. Yeah, you know. Okay, and it should not throw. Yeah, okay. So it does. It does. It does. So, as let me just go log info. Being called here, which should not be done. Make clean L and make Linux. Then we run it and then we close it. And does it say being called here? Nope. But it does say that shadow byte represent, okay, right, shadow bytes around buggy address. Okay, so if we left heap red zone, this F9 global red zone. Okay, what is a global red zone, right? So we go. Sorry. Yeah, I forget. In the context of Linux, the global red zone refers to a 120 byte below the stack pointer that is reserved and safe to use. Okay. Which is okay. In the computing, the red zone is a fixed area in function stack frame below for a position stack. The current stack pointer that is reserved and safe to use. It is most commonly used in leaf functions that don't call other functions, for allocating additional stack memory without moving the stack pointer, which it saves an instruction. Okay, so what is happening? What's happening is 940. Can I say where is 940? Okay, 940 here is being allocated before quit defined in source here of size 1. Yep, and allocated 0 byte 940 is allocated 32 bytes after titles tiles. Okay. I don't really get this. Right. Okay, so the only thing I can that I'm accessing this place right here. Right. That's that's all I can make of it, that I'm accessing that place. Okay. And it's still hmm, no, I'm no longer okay. So we got that right. Don't forget I shouldn't really have to do that, because it is outside. And okay, anyways, so we go make clean L, then we go make Linux. Let's try that. I'm not okay. Even if I access that memory, is that wrong? Right. Okay. Being called here, being okay. So if I don't access that memory, I'm right. But if I try to access that memory, it gives me a little bit of headache. Right. Okay. So back to what's the time? Okay, it's been half an hour. So let's get back on track. Okay, so we want to STL to wiki category. Not really. Let me go to index. Yep. Okay, RW ops. It was still 2 slash game controller read write. Render format. No, thank you. RW, yeah, RW ops. Okay, RW ops is a struct. Add a file. Index. Okay, give me 2. SL2 is over here. Here you go, functions. RW. Right, let's delete there the underscore. Okay, let's say ops. Yeah, RW ops. Okay, RW ops, STL read write operations. Then rw ops open, rw open. um,
अच्छा हो गया शिवाय मौसम शिवाय अच्छा हो गया.
okay, so here is this we declare a bool, right? Tiles loaded equals true. Okay, bool tiles. So I have this function bool set tiles. Okay, maybe yeah. Let's leave this and let's define it. Before and before update root media, maybe here. Okay. Loading the tiles, right? Okay, so we go bool set tiles. We take an array of tile pointers. Okay. Take an array of tile pointers. Then we set a success flag. Bool tiles loaded equals false. We go then tile offsets. We have tile offsets, which is x and y equals 0, and then open the map. Then we go open the map. I am going to use an SGL read write operations. Map equal SGL. I think I just saw that. SGL RW ops SGL RW from read write from file. Okay, read write still read write from file. So return values say return a pointer, a null on failure, right? Okay, so we can go still get error, right? Say it from file and mode is I want to open for reading, so I pass in a R, right? So we go assets slash assets. We have lazy.map comma in mode read. Then we check and then we go return false. And we check map should not be functional, else error fail to load the file. STL error is fail to load the file. Then we provide the STL get error, right? STL get error function. Okay. Anyways, I can okay, then we go back, then we okay, so we say that is done, and then we go initialize the tiles. Okay. Then we initialize the tiles, which is we loop through the tiles int I equals 0, I less than I guess total tiles, and I plus plus, like you will give a little space. Then we have determine what kind of tile will be made. Okay, how do I read? How can I read? Right, W read. Okay, we have, then we avoid pointer. A pointer to buffer the size of each object to be read in bytes, and the maximum number of objects to be read. Hmm. Okay, remarks. This function read a max num objects of each size from the data source to the area. Read from file pointer. Okay, see, by default it opens the file must exist, and okay, so the mode string is treated roughly the same as in C libraries fopen, even if STL doesn't happen to use fopen behind the scene. Okay, file, then hits some memory, creates an empty file for writing. A file with the same name already exists, its content is erased and the file is treated as a new empty file. Okay, file, in order to open the file as binary, this is additional the ability sometimes appended to make it explicit the file is a text file. Okay, so I can append a T right here to make it a text file. Then we go initialize, then I can go initialize my pointer. We want to read okay, where am I want to determine what kind of tile will be made. So determine what kind of tile will be made. We go into tile type equals -1, depicting none of the types. Then we go read if there was a problem in reading the map. Okay. So file pointer. Okay, so we want to read the, and I can read it is context. I go reading from the file. So, okay, why am I initializing it to -1 again and again? Is it if tiles loaded equals false? Okay, in tile type determine what kind of tile will be made. So it declares this again and again. When you go tile type, okay, tile type if there was a problem. Okay, so we check STL. The function is STL RW read STL. So we go size T RC read count equals to STL RW read. I believe that is right. Then we provide this context which I have map. Then I provide the pointer which is tile type. Then I want the size of each object, size of tile type, and then size maximum. Okay, we also only want to read one object at a time. So we check RC equals 1. Then the error, fail to read from the file. Read from the file, and then STL error is this. STL get error. Okay, here we go. This right. Then we okay. Yeah, tiles. Okay, great. Okay, then if the number is and if the number is valid, tile number. Okay. Now to check if the tile type is valid. Don't recognize. Okay, so check tile type. Say uh, should be greater than equal to 0. What tile does have 0? Okay, 0 to 11. Right. Yeah, let's see. Okay, check tile type. We put this in a whole condition. And then we go and tile type. Okay, tile type. I should enclose it. Yeah, right. Um, and here ends my error. Okay, so tile should be greater than equal to 0 and tile should be less than equal to 11. Right, I think that is the total tile sprites. It is less than. Okay, and total total tile sprites. Yes, total tile sprites. Okay, error. Invalid tile type. Then we go quickly. We jump out. Then if the number is valid, so we go tiles of I. There we go. Tiles of I equals the function to create a tile. Tile underscore create x, y, and tile type. Okay. Tile underscore create x, y, and tile type. Okay. Then if the file is loaded successfully, we have a for loop that reads in all the numbers from the text file. We read a number into a tile type variable and check if the read failed. If the read failed, we abort. If not, then we check if the tile type number is valid. If it is, we create a new tile of the given type. If not, we print an error and stop loading tiles. Okay. So we go move the tile spot. Okay, move the next tile spot, and then we move to the next tile spot, which is x plus equals to tile width. Right, should be tile width shifted by 80. Then if we reach the end of the level width, we reset. Right, so if x is greater than equal to, right? Yeah, greater than equal to level width, then we can go x equals 0. Okay, we reset x and move to the next what is next row. that is incrementing y. So we go y plus equals level height. Okay, level height, right. And after loading a tile, we move to the text tile position to the right. If we reach the end of the tile, we move down the next row. Okay, so let me, if tiles loaded, done tiles loaded. I think tiles loaded is true by default. Yeah, right. Loaded is, this is true by default. And we go return tiles. I don't need this then. Right. Then we go return true. Okay, so let's try and do this. R equals set tiles. Tiles. Nothing. Then we check. R should not be equals to false. Error. Fail to load the tiles. And let's try and make this. Okay, tiles unknown. Right. Set tiles game.c89. Game.c89 set tiles tile. Right. My bad. Let's try that again. Okay, so we get resource temporary unavailable invalid tile type. Okay, so say failed to load. Something went wrong. You're right. Okay. So error resource temporary unavailable. Error invalid tile type. Game.c 109. Game.c 109. Check. Okay. My bad. Okay. This is this with this, and this bracket matches with this, right? Okay, so maybe I should. Okay, so leaks and memory, the direct leak one allocation where main. Okay, so we will make clean L, then we will make Linux, then try and run it. Okay, invalid tile type again. Invalid tile type again. Why do I do? No, this is okay. Error invalid tile type. Resource temporary unavailable. Okay, so alright, so here are some of the changes I made. Okay, so since it was reading text data, so I declared a temporary temporary string for reading text, right? Then we go to reading from tile, we read from the file. Then I have to convert this string back into a tile type. Also, I got rid of the extra zeros that were used here, so that it only takes 2 bytes. So it reads only 2 bytes, like from here to here and then here to here and so on. So then we assign, then we create the tile types here. You can get rid of this maybe. Okay, then we will go clear and make clean L. Okay. So I have 1200. Alright, okay. This seems about right. Okay. Then we come on here. We want to clip the sprite sheets. After this, after the for loop, this is a loop, right? I want to clip the style sheets. So we go tile clips red. I think I already have the style clips. Yeah. Total tile sprites 12. Okay. So we have tile clips. We get this here and get this here. So we start with red. Tile, is it tile clips? Tile clips, yes. Okay. So tile clips of tile underscore red dot x equals 0. Y equals 0, and then we take the width and the height, which is tile width and tile height. Yeah, I think in the tile render function I do make use of this clip. Yeah. Okay. So we go. And I do make use of the tile box camera X, tile box camera Y. Okay, good. Okay, now I got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, then we go to tile green and we get 80. Then we go to tile blue. This is 160. We go tile top top left. This is 80. Then we go tile left. Tile left, which is 80, 80. Okay, continuing on tile left, and then we tile left, then we have tile bottom left. Okay, so bottom left is 80 and 160. Then after bottom left we move on to top, which is 160 0. Then center, which is 160 80. And then we have bottom, which is 160 160. Then we have top right, which is 240 0. Then I have right, which is 240 80. And finally I have bottom right, which is 240 and 160. Okay, then I close the file pointer. Just close. It's just map. I hope this is it. Close. Yep. RW. Okay. C is small. Okay. Right. 0 and success, and it doesn't really matter to me, but let's try this. It connects. Okay, so it is all messed up. Yeah. I don't think it's supposed to look like that. Okay. Anyways, so I have this A to I log this, maybe Albert. Another file. I seriously don't get it. Why? Okay. I go make clean L, and then I go make leave L. Right. Make. So that and a seg fault. Right. Being called here. So there's something obviously wrong with this, which I cannot see. Maybe, okay, if I remove the deallocations, right? Okay, so how is it that this geolocation is I don't know, man. which has a static right. This is a static array of pointers. Okay. Static array of pointers. Pointing to an array of array of pointers. Okay. Does anything created on the stack gets deallocated by itself? Okay, I'm trying to understand. Sorry, thank you. I'm trying to understand how deallocation of stack will be treated. To be precise, I'm trying to understand it. Malek free test. So test has, because we have deallocate it by ourselves, yet test still has automatic storage duration. The standard describes various. An object has a storage duration that determines its lifetime. There are 4 storage duration: static, thread, automatic, and allocated. The lifetime of an object in the portion of program execution during which stage is guaranteed to be reserved for it. An object exists an object exists, has a constant address, and retains its last stored value through its object is a portion of the an object exists as a constant address and retains its last stored value through its lifetime. If an object is referred to the behavior is undefined, the value of a pointer becomes indeterminate when an object it points to or just reaches the end of its lifetime. For such an object that does not have a variable length array type, its lifetime extends from entry into the block with which it is associated until execution of that block ends in any way. Okay. Entering an enclosed block or calling a function suspends but does not end execution of the current block. If the block is entered recursively, an object is created each time. The initial value of the object is indeterminate. If an initialization is specified for the object, it is performed each time the declaration or compound literal reached in the execution of a block. Otherwise, the value becomes indeterminate each time the declaration is reached. Okay. So you're pretty much correct. It doesn't at all describe when and how storage is deallocated per se. It only specifies when the storage is accessible with well-defined semantics. An implementation need not deallocate the storage of a variable with automatic storage generation right away. You just can't touch it if you want your program to be standard compliant. For allocated storage, the same goes, with added caveat that you have to explicitly tell the implementation you are done with the storage. But even if you do free it, an implementation may hold on to it still for a while longer. Okay. It's possible on paper. It is possible on paper for a very poor implementation to exist, one which never deallocates memory, but in practice those are culled naturally because poor implementations just become disused by the masses and abandoned. Okay, so see, don't forget to initialize it. Okay, so I was wrong in freeing the memory of the objects allocated in this array, since it's declared on the stack its lifetime, and hence the allocation will be handled on the stack itself. Right, So what I am doing here is wrong, right? So what I am doing here is wrong. So let me go make clean L, then make Linux. That is okay, and that is perfectly fine, right? So I don't need to deallocate it, and nor do I need to compare because it is on the stack, right? Because it was on the stack. So okay, now on to setting up our tiles. Yeah. Okay. So bool set tiles. We get this. Let me go. Login for tile type. Tile type. Tile type of, let's say, I. So let's make Linux again. So let me see. Okay, first of all, it should be 192, 191. Yes, right. And it should match the file that I have here. Okay, so we'll start. Okay, we got 0 1 2 0 1 2 0 1 2 0 1 2, then 0 1 2. Okay, hold up. 0 1 2. Yeah, I guess I can just print it, but I don't know when I will get into end. Oh no, I know when I will reach the end of a file. So let me just because loginfo is not really working here. Printf d, keep a space, and I put tile type. This happens, we print a new one. Thanks for trying out. No thanks. Okay, so the program is still running. Let's make it big. Let's clear it, and let's make Linux again. Bro, that is what? Right, I can just do into map.txt. I should have a map.txt with all these values, and yeah, it is different. It is oh well, it is really different. So I have completely lost the 11. Okay, so 0 1 2 0 1 2. Maybe I can do a def on map. Okay, def on map.txt and asset/lazy.map. Okay. So these columns are totally identical. String parsing is, man. Alright, so temp lazy map. Right, so we go with this. Then let me do it again. Hey, oh, okay, nice. Right, then I'll go map.txt. Okay, so now it is different. That's okay. Okay, indirectly, yeah, I don't care about that, man. And is valid. So let me go map.txt. Nothing. Okay. lazy.map, map.txt. Sorry, I have to print temp tile. Right. Okay, so we go with make Linux main. Okay. God, the horror. Okay, let's do map.txt. Let's check out where is map.txt. It's got a load. Right, okay, so this is incredibly wrong. Okay, okay, so 0 1 2 0 1 2 0 1 2 0 1 0 1 2 0 1 2 0 1 2 then 0. Okay, but most important of all, does it retain the values? Right, okay, so it does retain the values, but I'm reading a single byte here. Okay, so are there any hidden new line characters? Ah, man. Okay, let's try this again. Main, map dot txt. Okay, not quite right, but we'll see. Okay, still okay now. Man, I don't understand. Like, see. Okay, so is it supposed to take 3 bytes at a time? I think that would help, right? So we provide it with 3 bytes. Right. Okay. So we say you go with 3 bytes and what is another 420? No, 8. 8 is the 24. Like Linux. Okay, this looks somewhat preferable, right? Okay. So this looks better, way better. So we'll quickly take a look at the values. Okay, so map dot is empty. Map dot txt. That is okay. Show me map dot txt. What is this? Man. I think is specifying that the text help Linux. I don't think it helps. Right, okay. Okay, so I'm dropping this for a regular old file pointer. Yep. I will go file map. Close F open. Let me go man F open. Okay, so we path name and the mode, and the mode is read. Right. Okay, so I can go text file, fail to load the file, then I think I have man f printf file stream character format, and okay, I think it is supposed to be man f scanf. Yes, file stream. File stream, because I want to scan from the file. F scan F. Right. scan f from the file pointer, then the format, and then let go this. Okay, so let's try that. Okay, return values. On success, these functions return the number of input items successfully matched and assigned. This can be fewer than provided for or even 0 in the event of an early matching failure. Okay. So I go fscan f. I provide the file pointer, which is map, comma the format, which is going to be an integer, and then I go tile underscore type. Then I won't need to do this. Now this, that is good. It's not good for text files. It's good for binary files. Okay, tile types, tile. Okay, so let's quickly log info tile type comma tile type. Let's try and make that. Okay, so I forgot. I have to go fclose map. Okay, it needs a right because I have to provide its address, and then I should be good to go. Okay, finally, so we have this. Okay. Nice. Fscan f for the win. Right. And we go make clean L. So that was all the problem. Should have used fscan f to the beginning. Okay, so the files are set and we have clipped. Right, now on to the next thing. Well, I wasted a lot of time on that. Okay, then we go it's greater than equal to center, and okay, so let me see which kind of that be. It is and top left. Greater than equal to center and less than top right, bottom left. Okay, greater than equal to tile center if the collision box touches the tile wall, if the tile is a wall type. Okay. Okay, great. So let me take a look at this tile. So okay, so all these black tiles represent okay, so we're going for, let's say, greater than center So we have top right, bottom right, left top left, red green blue and center. Okay, I think this is the center, right? This is the center, and then everything else here we are supposed to check collision with. Okay, so with the function touches wall, okay, dot touches wall, so let's implement this. Function to check collision with the tile walls, and I think I already have this dot touches wall. Yes. I would also have to provide. Okay, I'm providing const flux accord, but I think I'll just provide the dot itself. So indeed, though, when I think about it, dot touches wall. Okay, this is good. Dot touches wall. We provide the dot itself. Right. Okay. Then we go through the tiles and we check if the tile type tile of I, and we provide the box and box of the. Okay, so simply iterate over the tiles, total tiles, okay, and if the tile is a wall type. So I less than total tiles, that's too many tiles, I plus if the tile happens to be a wall. Okay. Okay, then maybe I will just so we put a condition if tiles of I of I think I suppose it's type. Yes, it's type is greater than equal to tile underscore center, and tiles I of type is less than equal to, what is the last one, tile top left, right, less than equal to tile top left and tiles. Okay, so the touches wall function checks a given collision box against a set of tiles. Tile center, top right, tiles and tile underscore center, tile underscore top right, tile bottom, yeah, tile left, tile top left, all the tiles up to all the 8 tiles leaving the center. Okay, you'll see that these numbered right next to each other, so all we have to do is check if that type is still center, and you can calculate for any tile. There's a wall function returns true. Okay, if I hope the check collision, yes, checkbox collision, I think this is in collider, check box collision, so I will have yes, go if check collision, if the collision box touches the wall tile, if the dot touches the wall tile, if check box collision. It takes checkbox collision, a collider A and a collider B. Dot box, I think, right? Dot box, and then for the tile. Oh yes, no, sorry. Box and tile of I. Tile, I believe, also has a box. Auxiliary box, yes. Tile box. If so is the case, we return true. Else we return false. So let's try and see this happen. Wait, tiles I of box. Alright, so we go ampersand. These are static objects, and ampersand right, because we have to provide, right, okay, by reference. Next, and we fucked up something. Read of size 4 at 32. Okay, so I have a box here and the tile. I also have a box here. Check collision. Dot touches wall, or dot touches wall, dot touches wall. Okay, so yeah, okay, so my bad. I will just pass in the dot here, and I will just pass in the dot here. Dot and tiles, then dot and tiles, right? It's just, first of all, just clear now. Then we go make an X. Yeah. Well, I would need to spawn my dot at 0, 0. So let's do that really quickly. Dot at 0, 0. So let's make it again. And okay, see here it can't go any place else, and should, right. So there we go, our tiling engine is complete. Then tile set, load media, dot set camera, I've done that. Render, I render that, and that is all.